Okay, so this is the second part of the test number 2, first 6 weeks video. First part was made earlier today. It's already been uploaded onto the class website. So and we work on problems 1 through 5 on that. So if you want help with that, please watch that video. It should already be uploaded. This one here, we're going to finish on and do 6 through 10. This one should be pretty straightforward. Now remember, on the test, you're not going to have formula sheets or anything. You're going to need to know these formulas. It says if $8,500 is invested in a long-term trust fund with an interest rate of 10% compounded continuously, what is the amount of money in the account after 25 years? Now just a quick lesson, anytime you're dealing with interest rates, compounding, money, stuff like that, you're going to use one of two equations. You're going to use this one, or you're going to use this one. If you'll remember from classes, we use this first one right here every time with one exception, when it's compounded continuously. So as long as it's compounded continuously, we use PE to the RT. Everything else is P times 1 plus R over N to the NT. And are you going to ever have to guess if it's compounded continuously? No, it will say it in the problem. And if we read this problem up here, it does say it's compounded continuously. Therefore, we're not going to use this top expression. We're going to use this bottom one here. So now we have A is equal to PE to the RT. So now all we have to do is figure out what it is we want to find and how to plug the numbers in. So the question says, what is the amount of money in the account after 25 years? So we want to find A. A is the amount that we want after a specified time. So to find A, we need to know what P, R, and T are going to be. Well, P is the initial amount. It tells us that we start off with 8,500. And E is always E. It's not a variable. It's actually a constant. Raised to the RT power. Well, R is our interest rate, but remember it's in proportional format. In other words, we move our decimal place 2 places to the left and drop the percent. And then time is time in years, so that's 25. So now it's just a simple expression. So A is going to be equal to this stuff right here. Now, having done that, let me bear with me for a second while I group these and slide it over because my calculator is going to cover it. All right, so we got the calculator here. So now all we got to do is just figure out our stuff. So remember your order of operations. Take care of your exponents first. That's 0.10 times 25. And then you're going to multiply that times 8,500. And that gives you 103,000, if I'm reading that right, 103,551.1987. So since we're dealing with money here, it's 103,551.20. Again, if you take a look at the screen there, that should round to 20 cents right there. So if you start with the 85,000 and over 25 years it grows 10% each year without adding any more money to it, you should have $103,551.20 when you're done. All right, so if you're working on this, I'm going to move to the next slide, so you may want to pause this and copy it down. So here's the next one right here. Number of bison per acre of range in the wild is N is equal to 2.5 times 10 raised to 5 minus 0.004 W, where N is the number of bison per acre, W is the average weight of the bison in pounds. Find the average weight of the bison in a herd that has an average of 4 animals per acre of range. So we got a lot of information in there, so it helps to understand what these different things mean. So I'm going to write this out right here. N is equal to, and I'm going to write this different. It's 2.5 times 10 raised to the 5 minus 0.004 W exponent. Now that's a little bit different. Scientific notation has a base of 10 like that. Notice I wrote it just a little bit differently. All right, so we need to know what N is. Well, the N is the number of bison per acre. And what is W? W is the average weight of the bison in pounds. So the question says, find the average weight, or in other words, find W, of a bison in a herd that has an average of 4 animals per acre. Well, remember, N is the number of bison per acre. So the average is 4 bison per acre. That's the expression you want to work with right there. 4 is equal to 2.5 times 10 raised to the 5 minus 0.004W. And again, notice how I wrote my expression down a little bit differently than what you see in the problem. 10 is the base, so I put it in parentheses. That makes it a little clearer to see. Right now, it's just a matter of going through the algebra. I'll work through this one by hand. First thing we're going to want to do is divide both sides by 2.5. Okay, and if I take 4, excuse me, put that down. Well, the board, you pause it. Okay, I had to pause it there for a second. If you take 4 and divide it by 2.5, right, you get 1.6. So just writing this out, so I have 1.6 is equal to, not 2.5, is equal to 10 raised to the 5 minus 0.004 power. So now we have base power answer. If you'll remember, I'll put this over here. Base raised to a power is equal to the answer. Transfers to log base answer is equal to power. The BP and the A are the same in both problems. So we know B is 10. P is 5 minus 0.004W. Forgot that in there. And A is 1.6. So now I have log base 10, right? That's the base of the answer is 1.6 is equal to 5 minus 0.004W. So now algebraically, log base 10 of 1.6, that's a number. All right, we can find that in the calculator pretty quickly. We'll do that in a second. But to get W by itself, what I'm going to need to do is subtract 5 from it and divide by 0.004. So I'm going to write it out like this. Log base 10 of 1.6, that's the base 10. All right, log base 10 of 1.6, and I'm going to subtract 5 from that and divide the whole thing by negative 0.004. It's going to give me W. So now it's just calculator work. And remember, log base 10 of 1.6 is just like saying log 1.6. That's what that number is. I'm going to subtract 5 from it. And I'm going to divide by negative 0.004. And the answer I get, W, is approximately equal to, of course in rounding terms, it's 1198.97. Now, whether this is the actual correct answer or not is dependent on if it's multiple choice. This could easily be a multiple choice question. It doesn't have to be open-ended. But it says here, it says, find the average weight of the bison. So since we're talking about weight, we're probably going to get by with leaving that as a decimal. And of course, that was in pounds. Am I correct there? Go back up here. It says, yeah, bison in pounds. So I'm going to go ahead and just add that suffix there. So the weight is 1,198 pounds, 1,198.97 pounds. That's the average weight when there are 4 bison per acre. So if any of y'all are aspiring buffalo herders one day, hopefully this will come in handy to you. We've already had that talk about whether this is handy or not. All right, so again, let me go back to this. If you didn't get it, you need to copy this down, rewind the recording, and look it over again. All right, the next problem here, number of bacteria in a culture is modeled by that expression. N is equal to 200 e to the kt. This looks a lot like a problem we did earlier today. T is the time in hours. If the N is 360 and the T is 3, what is the time required for the original population to quadruple in size? So in order to do this, you have to understand a few things with this. Number one, what N and T are. It says here that N represents the number of bacteria in a culture, and T represents the time in hours. So it wants to know, what is the time required for the original population to quadruple in size? So if we just start off with the expression, N is equal to 200 e to the kt. If we just simply looked at that right there, and we said, all right, well, we want to find T. Well, to find T, we need to know what N and what K are going to be. So we got a double whammy there. First thing, we're not sure what N is going to be. Well, here's 360. That's what it says up there. Not true. We want to know what T is going to be when the original population has quadrupled. When the original population is quadrupled. So N is going to come from this expression right here. And then we got to find K. Well, K is a whole different animal. To find K, we need to know an N and a T that correspond to each other. Not just any N and T, but an N and a T that correspond to each other. So we actually have to work this out in a couple of steps. Therefore, first what I'm going to do in blue, we're going to find K. Because if we read the problem up there, we know that when we have a correspondence, we know that when N is 360, T is 3. So we know this. 360 is equal to 200 times e to the 3k. That's what we know right there. All right, now it's just a matter of actually doing some solving. And we could go through the steps that I did that earlier in the previous video. So if you watch the previous video, I'll walk through a lot of this step by step. This one I want to go ahead and cut to the chase. I know that if I have a base of e, I'm dealing with the natural log of 360 over 200, whatever that number is, right? And then I'm going to divide that whole thing by 3, and that's going to give me what k is. So I need to find the natural log of 360 over 200 and divide that by 3. Now I'm just checking my math here. I know I need to do 360 over 200 natural log divided by 3. So we're good. All right, so the natural log, clear all that off. The natural log of 360 divided by 200. That's an answer there, and I'm going to divide that number by 3. Okay, now again, that's a long number. Unless you're told differently, always round to 3 decimal places. That gives us consistency. So K is approximately equal to 0.196. For those of y'all who can't read the screen, it says 0.19592888883, just like that. So now we know what K is. So K is 0.196. Now to answer this problem, though, we need to know what T is going to be when K is 0.196. We got to put in a number for N. And again, you don't just simply put in 360. N is the quadruple of the original population size. Well, how do you find the original population size? Well, that's when T is 0. Right? 0 always represents the initial. So if I take 0 and multiply it by K, I should get 0. And e raised to the 0 power is 1. And 1 times 200 is 200. So the original population is 200. Quadruple 200 is 800. Now that took a little bit of thinking, but like I told you, if your exponent is solved out to be 0, your original number is always whatever this constant is going to be. So the original population is 200, quadruple is going to be 800. So now it's just simply a matter of a logarithm. So again, if you don't understand how I get to the next few steps, watch problems from the previous video. It walks through that kind of stuff step by step. Now I'm not going to walk through it step by step as much. I know I need to take 800 and divide it by 200. That's going to be 4, but I'm going to write it out this time. Is equal to 0.196t. So the natural log of 4 divided by 0.196 is equal to t. The natural log of 4 divided by 0.196. So the natural log of 4 divided by 0.196 gives me 7.07, just like that. So if we round it, 7.073. And again, this could very easily be a multiple choice question. And then it's to say about 7 hours or something like that. But the key to this problem is knowing that you have to solve for k, and then also knowing that n is not 200 or 360, it's actually quadruple 200 on that. So again, if you don't get this, just make sure that you pause the video and copy it down, and then rewind it and listen to what I have to say, and of course ask questions when you have them. Next one here. Oh, we've seen one just like this in class. Find the population, or the population of Lincoln, Nebraska. That's what NE stands for, Nebraska. Is 548 e to the KT. T0 represents the year 2000. In 1980, the population was 172,000. Predict, it says predict the, TH, but I should say predict the population in the year 2021. So this is much like the previous one. We want to predict the population when T is going to be 21. Now the reason we're using 21 is because 0 represents 2000. 2021 is 21 years past 2000. So for us to solve this, we would have to know what our K is going to be. We don't know what it is right off the bat. But do we have a situation where we have both a time and a population that correspond to each other? We absolutely do. So we can find K off to the side right quick. Right? K, we know that when the population is 172,000, time is going to be -20. The reason it's -20 is because if 0 is 2000, 1980 is -20. And the other thing is, you notice I just put in 172, not 172,000. We had this talk in class. The reason we're doing that is because the population is already in thousands. So either we have to tack on 3 zeros to both constant numbers, or leave it as 172 is equal to 548. Right? And again, going straight to the math here, the natural log of 172 over 548, that whole thing divided by -20, that's going to give us K. So put in the calculator. Let's go ahead and clear this a little bit. Natural log 172 divided by 548 is that number there, and we're going to divide it by -20. And we get 0.057939, etc., etc. Rounding, K then becomes 0.058. Okay, so now the rest of it's easy. What's our population? Lincoln, Nebraska. 0.058. 0.058 when in the year 2021. So that's going to be 21 right there. I know the calculator is going to cover it up, but let's just go ahead and leave it like that. So I want to do E raised to the 0.058 times 21. That gives me 3.38, etc., etc. Then I'm going to multiply it by 548. All right, so I get my P is 1852.470. Again, we talked about this earlier in an open-ended question. That is actually not a correct answer to leave it like that, because you're saying the population is only 1,852.47 people. We know the population is in thousands. So one thing to do is to write this out in thousands. So that would be 1,852,470. Or write the word thousands on the end. Again, in an open-ended situation, that's what you would want to do. If this was multiple choice, you would check answers with that. So again, if you have questions, pause this video, copy this down, pause it, and then rewind it, listen to it a few times, and then if you have more questions, you can come and talk to me. We got one more to go. This talks about money in an account. We've seen a problem like this before. We have data that represents the amount of money an investor has in an investment account, starting in the year 1990 through 1999. We have all of our stuff right there. This one says find the exponential model for this data. And then there's a second part. It says if the investor plans on retiring in 2031, how much money will she have? So to find the exponential model, and again, we don't have to concern ourselves with whether it's linear or exponential or anything. It tells us that. First thing we're going to need to do is put our numbers in the calculator. So you hit Stat and Enter, and you should put your numbers in L1 and L2. Now, if you notice these numbers here, they're not the numbers 1990, 1991, 1992. I put them in by saying that, I said, all right, in my mind, I said, let's let 1990 be 0. Next, I'll write it out over here. Let 1990 be 0, 91 be 1, 2, 3, 4, 5, 6, 7, 8, 9, just like that. And the reason we want to do that is because if we put in 1990, 1991, it's going to read it as the year, as the number 1,990, 1,991, not as the year. Also, if you put in huge numbers like that, you could end up overloading the calculator and wouldn't be able to calculate numbers that high. So even though it doesn't tell you to do that, definitely start your years with 0, or you can make it something simple like this represents the number of years after a 0 year. For instance, if this data set started in, say, 1995, you could say each year is the number of years after 1990. All right, in this case, it starts at 90, so we're going to use these numbers there. And then, of course, in your other list, type in the values, make sure they correspond, make sure you got them in correctly. And then all you need to do is go to Stat, Calc, and then you need to scroll up or down. I'll scroll down in this case to 0, exponential regression, EXP-REG. Scroll to that one right there. Now, depending on what your calculator looks like, some people may get a screen that says X list, Y list, frequency list, like that. Others might get a screen that looks like this. It just says EXP-REG with parentheses. Either way, you need to tell it to pull your X list from wherever you put it and your Y list from wherever you put it. I happen to put my X list in L1 and my Y list in L2. Frequency doesn't matter in this case. I'm not going to store it like that. So we're just simply going to calculate it. It takes a second, but we get those numbers there. Now, some of you may have R squared and R on your calculator. Don't worry about that for this part. Now, by the way, as an aside, if your calculator screen doesn't look like mine, you need to put in L1, comma, L2. And the way to get to L1 is second 1, and the comma is above 7 key on the calculator. You look at the 7 key, the comma is right above it. And of course, L2 is second 2. All right, but no matter what, our exponential model, rounded to 3 decimal places, is 1,014.496, parentheses, our base is 1.057, base of the x. So the value of the account is based on that model there. Now it wants to know, this investor plans on retiring in 2013. How much money will she have? So all we need to do is put in a number for 2031. I said 13 a second ago. 2031 would be, if 1990 is 0, 2031 would be 41. You count it, right? 1990 is 0, 1991 is 1, 1999 is 9, so 2000 is 10. So 2010 is 20, 2020 is 30, 2030 is 40, plus 1 is 2040. 2031 is 41 years. So we want to plug in 41 for x. So what we're going to have is 1,000 or 10,014.496, 1.057 raised to the 41st power. Okay, several ways to do it in the calculator. In this particular case, I'm going to do it like this. I'm going to physically type it in. 1.057 raised to 41 times 10,014. So this person after 41 years would have $97,203.54. Again, this could be an open-ended or multiple choice question. They both work the same. So this video, along with the previous video that was made, are both going to be uploaded onto the class website, and if possible up on YouTube also. They explain all 10 problems on the review, and hopefully this and all the other stuff that you've done will give you ample study material for the test.